Hi folks, this is Dr. Don. A little bit late on this week 7 video, but I wanted to go over a few things with you uh, that have to do with the remix. And again, we're in week 7, which is lab 7, and this is about comparing proportions. Okay, before we were looking at means, and these are proportions. So these are categorical variables, just have names, so to speak. Labels. They don't have numbers that we can add and subtract. Rehearse 1 was comparing 1 and 2 proportions. This is kind of like the one sample t-test, comparing one proportion to a benchmark value, equal, greater than, less than. And then 2 proportions, comparing those to each other, again, greater than, less than, equal. And then the second rehearse is on multiple proportions. And that's the one I want to talk to you about. I'm going to go over here and click. And again, this is my standard setup. I've got the lab manual home page, Rehearse 1 tab open, Rehearse 2 tab open, Remax tab open, and I've got this Infer pipeline page, which is the folks that build the Infer package, and then my workspace here in Posit Cloud. Let's go over here and look at the remix. And specifically, I wanted to talk about research question 2. Okay. A lot of folks in past classes have gotten this wrong for a couple of reasons. And if you read this, it's talking about the gambling CSV, and it wants to know, is there a difference between poll participants who are and are not gamblers on whether gambling should be online or not online? And when you look at the data, you find out that there are 2 categorical variables, but they only have 2 levels each. And I have a note here. That's the classical test for independence. The Infer method, if I get a chance to update this, I'll make that a little bit clearer, cannot be used for this particular question. So you need to look at one of the other options we have here. It's definitely not a goodness of fit test because it's only 2 by 2, and it's not a test for independence because it's only a 2 by 2. If we look here at the Infer pipeline, and I got this first one here, and this is a 2 by 2, and we're looking at the difference in proportions. If we go down here to categorical variables greater than 2 levels, we get to the chi-square test for independence, and that's what you would do if you had more than a 2 by 2. 2 categorical variables with only 2 levels each. You need to have at least a 2 by 3 or a 3 by 3 or bigger. And this is the formula you use. What has happened, though, some students will attempt to use this formula, and of course it won't work. It'll give you an error because it doesn't know what success is when you only have a 2 by 2. And some students have figured out that I can copy something out of the proportion Infer method and paste it in here. And for some reason, I think just pure chance, it does work on this particular set of data. But I want to emphasize the reason that the Infer folks have not changed this standard here, the examples here, it's all still a greater than 2 level, is because of those anomalies. So do not change this code when you're using the Infer code that they give you. Don't create something on your own. So I wanted to show you here. I picked up a data set about the Star Trek uniform color. I don't know if you're a Star Trek fan, but there was a discussion a couple of years ago about each type of person in Star Trek has a different color uniform. And some people had surmised that a certain color uniform was killed off more than the other color uniforms. And that's what this was about. And This is the Star Trek CSV, and I'll make this available later on. When we look at the head of the tail, you can see we've got the color of the uniforms, blue, fatality yes and no. And if we go down here, I got the unique values that we show you how to do. And it's blue, gold, and red in this example, and yes or no on fatalities. We had a couple of plots here showing the fatalities by color uniform. Blue, gold, and red. You can see blues have a lot more fatalities than the other colors. Excuse me, and I apologize. I haven't taken the time to give or a specific color here. That's why it bad example. I need more time because it shows it's a red uniform is colored blue, blue is colored red, and gold is colored green. But you get the idea. There are some codes we can use. I just don't want to take the time to do that right now. And then we got the counts. And then we stated the null. There is no relationship between color uniform fatalities for the null, and there is a relationship for the alternative. State significance level, and then go through and calculate the chi-square statistic. And this is where those students mess up. When you've got a 2 by 2, it'll give you an error message unless you specify success. And that's where they get into trouble. They will copy that out of the other example and include that specify success. You know, a certain color is the one they're interested in. And then this appears to work, but it doesn't really. I just want to emphasize that. Do not modify these codes. Use what the Infer folks. And again, we can see we got a stat up here of 6 something, and we got the p-value 0.047, which says, yes, the uniform color does make a difference. So anyway, that's what I wanted to talk about today. If you need any help on anything, reach out, give me an email, course email, and we can have a Zoom if you need. Hope you have a good week.